Our next topic is related with boiling point elevation. So here, calculate the boiling point elevation and the boiling point of a sugar solution by dissolving 218 grams of sucrose in 756 grams of water. The molar boiling point elevation constant of water is 0.52 degrees Celsius per molal. So first is to write the given here. Here we have the amount of the solute. The solute here is sucrose, and we have the solvent, which is the water. Again, we'll use the variable A for the solute. Again, that's 218 grams of sucrose, C12H22O11. And the solvent here is the water, it's 756 grams. And also given on the problem is the constant or the molar boiling point elevation constant for water, which is 0.52 degrees Celsius per molal. Let's focus on what we are finding here. First, we need to find out the boiling point elevation or the change in the boiling point. That's equal to the constant multiplied by the molality of the solution. So obviously we have already the constant. Now we need to find out the molality of the solution. So let's find out the molality of the solution. So again, the molality, as we discussed before, is equal to the moles of solute over the mass of solvent in kilograms. So we need to find out these values first. Okay, first is we need the moles of solute, but here the given is the mass of solute, so we first need to convert this mass into the number of moles. And to do that one, that's 218 grams, C12H22O11. Let's multiply this with the conversion factor. Again, to multiply, we need to cancel grams and convert this one to moles of sucrose. So 1 mole of sucrose is how many grams? And again, for this, we need to find out the molar mass of this molecule here. So we do let's add all the masses here. So CHO. The mass of carbon, if you check on your table of elements, it's 12, hydrogen 1, oxygen is 16. So here we have 12 carbons, 22 hydrogens, and then 11 hydrogens. That's equal to 144, 22, and then 176. And if you add this one, it's equal to 342 grams. So the molar mass of sucrose is equal to 342 grams. Now we can convert this one. So that's 218 divided by 342. 218 divided by 342. The answer is 0.64. Let's check that one. 218 divided by 342. Again, the it's equal to 0.64 moles. Let's continue finding the molality of the solution. Again, the moles of solute is equal to 0.64 moles. Next, we need the mass of the solvent in kilograms. Here, the mass is given in grams. So we need to convert this one to kilograms. So grams convert to kilogram. 1 gram is equal to 1,000 gram. And if you solve this one, it's equal to 0.756 kilograms. Let's put that in the equation, 0.756 kilograms. And we divide this one, that's 0.64 divided by 0.756 is equal to 0.85 moles per kilogram, or we can say this one is 0.85 molal. So that's the molality of this solution over here. So we now have the molality we can compute for the boiling point elevation. Okay, again, let's use this formula. Okay, so let's substitute the values. Here it's equal to the constant. Again, the constant is given on the problem. It's equal to 0.52 degrees Celsius per molal. 0.52 degrees Celsius per molal. Multiply this with the molality of the solution, which is equal to 0.85 molality. Again, that's small m. It's equal to, so we multiply this one, 0.52 times 0.85. The answer is 0.44. 0.44. This will be cancelled. This will be equal to, so the boiling point elevation, that will be equal to 0.44 degrees Celsius. So there's an increase of 0.44 degrees Celsius. So again, the boiling point of water is 100 degrees Celsius, and since we add a solute here, the boiling point will increase. And again, the increase is 0.44 degrees Celsius. So we simply add this increase, 0.44 degrees Celsius. And so the boiling point of the solution is equal to 100.44 degrees Celsius. So this one is the boiling point of the solution. And this one is just the increase or the elevation of the boiling point.